So you're diving into the C programming language, and pretty quickly you're going to realize you need a smart way to handle lots of similar data. Well, that's exactly what arrays are for. Today, we're going to break down this super fundamental concept. Let's get right into it. Okay, let's start with a real-world scenario. Imagine you're building a program for a school, right? And you need to store 1,000 test scores for 1,000 different students. So how would you do it? Just think about that for a sec. Your first thought might be, well, I'll just create a variable for every single score. And if you went down that path, your code would look something like this: a long, painful, and honestly what a nightmare list of individual variables. This isn't just a ton of typing, it's basically impossible to manage. There has to be a better way, right? And of course there is. This is where we bring in the hero of our story, the array. It's the elegant solution, a tool designed specifically for this kind of problem, organizing big collections of data, just like our students' scores. So what exactly is an array? Well, when you boil it down, it's really three main things. First, it's a collection of items that are all the exact same type. So all integers or all characters, you get the idea. Second, they all share one single name. And third, and this is key, they're all stored right next to each other in the computer's memory, in one continuous block. So remember that awful list of 1,000 different variables? With an array, it turns into this, just one single beautiful line of code. You declare the data type, int, give it a name, studmark, and then in square brackets, you just say how many you need. That's it. So simple, but so powerful. And what's actually happening under the hood when you write that line? You're telling the computer, hey, go find 1,000 memory slots that are all connected in a row and save them for me. The whole block gets the name studmark, and each individual slot gets its own address, or what we call an index, starting from 0. Okay, great. So we've stored all our data nice and neat. But what now? How do you actually get to a specific student's score, or maybe change it? That's the next logical step, and that's what we're covering right now. Now listen up, because this is probably the most important thing to remember, especially for beginners. In C and a lot of other languages, we don't start counting at 1. We start at 0. So the very first item in the array is at index 0, the second is at index 1, all the way up to our 1,000th score, which would be at index 999. It's a little weird at first, but you'll get used to it. And the way you pinpoint an element is super simple. You just use the array's name, and then right after it, you put the index inside square brackets. So right here, my number 0 points us directly to that very first box, which holds the number 2. Let's look at a quick code example. Here, we've got an array of integers called myNumbers. When we tell the program to print myNumbers 0, it knows exactly where to go, that first slot, and boom, it prints out the value 2. Simple as that. And what if you want to change a value that's already in there? It's pretty much the same deal. You use that same index notation, like RR0, but then you use the equal sign to assign it a totally new value. In this case, we're swapping out whatever was in that first spot and putting the number 1 there instead. You know, grabbing one element at a time is useful, for sure. But the real magic of arrays, the thing that makes them a true game changer, is being able to process every single element automatically. And for that, we turn to our good friend, the loop. The technical term for this whole process is traversal. It sounds fancy, but all it really means is visiting each element in the array, one after the other, usually from the beginning to the end. This is absolutely essential for doing things like, say, calculating the average of all those student scores we were talking about. And the classic tool for doing this in C is the for loop. Just take a look at this code. We set up a little counter, I, and we start it at 0. We tell the loop to keep running as long as I is less than 5, which is the size of our array. Inside, we just print the element at whatever index I is currently on, and then I++ just moves our counter to the next spot for the next time around. And the result? Well, it's exactly what you'd hope for. The loop runs through each index, 0, 1, 2, 3, 4, printing the value at each stop, giving us a perfect list of everything inside our array. Oh, and you're not just stuck going forward either. With a tiny little tweak to the loop's logic, we just start at the end and count backward. We can traverse the array in reverse. It's just that flexible. So, everything we've looked at so far has been a simple, one-dimensional list. But C is cool because it lets us take this basic idea and build even more complex and interesting data structures. This is where we make the jump from a one-dimensional array to a two-dimensional one. The best way to think about it is going from a simple shopping list to a grid, something like a spreadsheet or even a chessboard, which has both rows and columns.
And the syntax for this makes a lot of sense. To declare a 2D array, you just add a second set of square brackets. The first number usually stands for the rows, and the second one for the columns. So writing int matrix 3, 3 is like telling the computer to create a 3 by 3 grid for us.
And hey, why stop at 2 dimensions? A 3D array just adds another layer, another dimension of depth. The perfect way to picture this one is a big cube made out of smaller little blocks. Or you could think of it as a bunch of those 2D grids stacked right on top of each other. And as you can probably guess by now, the syntax just adds a third set of brackets. Now we can specify the depth, the rows, and the columns. This lets us model some really complex three-dimensional stuff right in our code. All right, so let's do a quick recap of the most important stuff. Number 1, arrays are your go-to solution for storing a bunch of similar items. Number 2, always remember we use a zero-based index. The first element is at 0. Number 3, loops are your best friend for working with every element in an array. And finally, remember that you can take this concept and build it out into 2D grids and 3D cubes for more complex data. So we've seen how arrays let you organize data into lists, grids, and even cubes. I mean, these things are the fundamental building blocks for everything from video games to scientific models. So the real question I want to leave you with is this. Now that you have this incredibly powerful tool, what kind of real-world problems are you going to go out and solve?